Hello and welcome back. In this video, we're going to talk about artificial intelligence and in particular, how we can create artificial intelligence in Unreal Engine. So first, we're going to talk about what artificial intelligence is. What is AI? AI is a branch of computer science, and it's dedicated to creating machines that act like humans. In games, examples of this would be NPCs, non-player characters, characters that populate a world and give the illusion of intelligence. Another example of AI in games is responsive experiences, things that change in response to user input. So if you're planting seeds or creating a garden on your island and it attracts some sort of animal or creature that eats your food, then this gives the illusion of a responsive environment. So how do we create AI in Unreal Engine? Well, Unreal Engine has some tools built in to make the creation of AI streamlined and efficient. Unreal Engine has behavior trees, which are extremely powerful AI creation tools in the realm of computer science. Behavior trees are based on branches that execute according to different rules that you set. The behavior tree depends on an asset called a blackboard. A blackboard can be thought of as the brain of the behavior tree. It holds information in the form of keys. Keys are user-defined, and they're sort of like variables. They have their own types, and these hold values that the behavior tree references in order to make its decisions. So let's talk about the overall structure of AI in Unreal Engine. First off, we have AI characters. Now, these are identical to the regular character class. In fact, you create an AI character based on the A character class. The only difference is that the controller used for an AI character is derived from the AI controller class. Now, an AI character typically has a behavior tree, which makes the decisions for the AI character. And the behavior tree depends on the blackboard to store data in order to make those decisions. Now, the AI controller contains all the code and functionality necessary to move the character. Now, AI characters require a navigation mesh, which enables the AI to navigate throughout the world, and it dictates which areas the AI can travel across. Now let's talk a bit more about behavior trees. A behavior tree is created in a visual way similar to blueprints. You create nodes in a behavior tree graph, and they're connected by branches. Nodes execute from left to right and from top to bottom in the behavior tree. In this picture, the flow of execution begins at the root and flows downward to the next node, and from there, it starts at the left and works its way down and across. The nodes have numbers on them to show you the priority, so you'll know which order they get executed in. Now, there are various types of nodes in a behavior tree. We're going to talk about a couple of them now. Now let's talk about the root node. The flow of logic starts at the root node and works its way down. Each node is attempted, and based on certain criteria, it will either succeed or fail. So the flow of execution will begin up here at the root, and it will attempt to run its child node, which is the node directly connected to it. This node will either succeed or fail. Now, if it fails, then it returns back up to the root, after which the tree will begin to execute again. Now, when the node runs, it will attempt to execute its child nodes. And each child node will then do the same thing, and it will either succeed or fail. Now, whether the node succeeds or fails, it returns that success or failure information back to its parent node. A node may attempt to execute all of its children or not, depending on the type of node. Now, if the node meets success criteria, then it will return that success information back to its parent. If it fails that criteria, it will return failure. When the root receives this information, it starts the tree all over again. Now, the way a node attempts to run depends on the type of node. Tasks, for example, are the simplest type of node. They perform a simple action. For example, the AI character may attempt to move to a player or move to a location. And if the AI character is unable to move to its target, it may return failure. And when it reaches the target, it may return success. Another type of node is the sequence node. The sequence node executes its child branches from left to right. Now, the sequence node will continue attempting to run its child branches until one of them fails or all of them succeed. Let's say this sequence has two tasks. It starts off with the leftmost child task. Now remember, the sequence will execute the child tasks until one of them fails. So if the first child task fails, then the sequence node will return the failure to the root, and it's said that the sequence failed, and now the root will start over. Now, let's say this first task node succeeds. Well, the sequence node executes its child nodes from left to right until it finds a failure or all of them succeed. So since the first task succeeded, the sequence then moves on to the next child node and sees if that child node will succeed or fail. Now, if that child node fails, well, now the sequence has reached a failure, at which point it can return that failure information back to the root, and the root can start over again. Now, let's say that task succeeds. Well, then all of the sequence's child tasks have succeeded, at which point the sequence can return that success information to the root. And now we can say that the sequence has succeeded, and the root is ready to start over. So now that we have a basic understanding of the root node and tasks and sequences, we're ready to lay a basic foundation for our AI character. We'll get started in the next video. I'll see you then.